All right, we are ready for Chapter 7, Lesson 2. Welcome to our flipped lesson for this chapter. And we are going to look today at how to verify trig identities. Yesterday we looked at simplifying. So really we're taking a big long string of trig functions and breaking it out into a simpler form. Today, kind of along the same lines, we're going to verify. In other words, there's going to be an equal sign in the middle. And we have to prove that the left side equals the right side. In other words, verify that two trig functions are equal or identical. Verify trig identities. Just two points. The first one is verify. We're going to have a great day. I know I am. Just a great day to study some math and pre-calculus, of course. Fantastic time to study pre-calculus. A couple of definitions today. Here is the first one. Transforming trig identities. Here's what it is. Transforming trig identities. To verify trig identities algebraically, transform one side of the equation into the same form as the other side. All right, let me pause there, continue writing. Transforming trig identities. To verify trig identities algebraically, what does that mean? It means to verify them using properties of algebra. Okay? Methods that we're used to with solving equations. What you must do is transform one side of the equation into the same form as the other side. In other words, make one side look like, be exactly the same as the other side of the equation. One more sentence here. Best practice is to first transform the more complicated side. Okay? And that just makes sense. You wouldn't want to take, in other words, if the right side was sine of x, you wouldn't want to try to mess that all around to look like the complicated side. No, take the side that looks more complicated. Work on breaking that down as much as you can. By doing that, hopefully then you'll show and verify that the two trig identities are equal. So one more time, how do you transform trig identities? To verify trig identities algebraically, transform one side of the equation into the same form as the other side. Best practice is to first transform the more complicated side. If you brought your book home with you or wherever you are right now watching this video, page 431 also gives a couple more good recommendations on how to transform these. Look there, middle page 431, it's highlighted in yellow. They say transform the more complicated side of the equation to the simpler side. That's what we just wrote down. Another good recommendation is to substitute one or more basic trig identities to simplify expressions. In other words, think the basic trig functions. Remember, we talked a lot about sine, cosine, tangent. If you get everything in terms of sine, cosine, tangent, things will be easier, especially sine and cosine. Things will be easier for you. Third bullet there, factor or multiply to simplify expressions. Again, algebraically, that's what we're doing. We're algebraically breaking these down. So you could factor or multiply to simplify expressions. Fourth bullet, multiply expressions by an expression equal to 1. So in other words, if you have something equal to 1, multiply a trig function or both sides of the trig equation by 1, or something that's equal to 1. Last one, express all trigonometric functions in terms of sine and cosine. That's always a good practice. But the last bullet point there on page 431 reminds us, transform everything in terms of sine and cosine. By doing that, you'll see things will start to cancel and shake out to be a lot simpler, and your trig identities will be verified. All right, let's look at a couple examples here under point number 1. Again, hopefully you have that definition down, transforming trig identities. Here's the first thing we want to do, verify that secant squared x minus tangent x times cotangent of x equals tangent squared of x. Verify that that equation is an identity. Verify that secant squared x minus tangent x times cotangent x equals tangent squared x. Verify that those two sides are equal. Okay? In other words, does all of this equal tangent squared? And if that's true, we have a trig identity. Which one's more complicated? That's the one we want to start with. It's pretty obvious, the left side. Okay, this side is more complicated. Here's where your handy-dandy formula sheet will come into play. Hopefully you have it with you. Remember the ones highlighted are the ones we are using. I might have a few more highlighted than you do, that's okay. get to the rest of this chapter. Notice we don't have that many highlighted, so you're welcome. We're not doing all these. What on our formula sheet can we substitute in for some stuff we have here? Okay. Again, thinking about our keys, especially if we can put everything in terms of sine and cosine. There's a few different ways to do this one. Okay, lots of different ways. We could change secant squared x into something. We could change this to sine over cosine, cosine over sine. Okay, lots of things we could do. For our purposes, okay, notice these two. These two are very similar. This is tangent of x, this is cotangent. Remember, cotangent is just tangent flipped. What can we change cotangent into? There's two things. Okay, we could change cotangent, into cosine over sine, or 1 over tangent. Doesn't matter which one, but let me show you. In this case, let's keep this here for now. We could change this to sine or cosine, but that's kind of an extra step in this case. What about if we just change this to 1 over tangent of x? Notice it's multiplied. Why do we do that? Well, what's tangent times 1 over tangent? They cancel, right? So is it 0? No, it's 1. So we're left with secant squared x minus 1. Again, equals tangent squared x. That's what we're trying to get everything equal to. You could have done sine over cosine, cosine over sine. It still would have canceled and you got 1. Okay? Again, trying to think, what can I break down? What can I change to simplify down this equation or to verify this trig identity? All right, do these look the same? Not quite. Let's stick with the left side. What about secant squared minus 1? Look at your formula sheet. Any ideas there about what secant squared minus 1 would be? Do we see secant squared anywhere on our formula sheet? I do. Under Pythagorean identities, right? Let's write it out. The kind of the formula here that I see with secant squared is tangent squared theta plus 1 equals secant squared theta. Remember, theta is just another symbol for an unknown, usually an angle. So x, theta, doesn't matter, same thing. Okay, unknown. Problem is, secant squared minus x minus 1, is that the same here? No. What did they do? Notice they just subtracted 1. So what is secant squared theta minus 1? Well, it equals tangent squared theta. So in essence, this, secant squared x minus 1, equals tangent squared x. What were we trying to get? Tangent squared x. That's all you would put in the blank right here. Okay? Your work is your proof, again. So, the answers are easy with this one on a test or quiz. If this is what you're looking for, your answer is just going to be tangent squared x equals tangent squared x. That's your verification. But it's the work that shows me how you got there is the key. All right, so we verified that this equation is in fact a trig identity. Again, a little help from the formula sheet, and able to work with a more complicated side to get an example or an answer that showed that those two functions, those two parts of the equation were equal to each other. All right, let's do another one. Let's see. I'm going to go a little bit more to the right here. So over there on the right. Verify that sine of A over cosecant of A you know what? I'm going to run over it. Let's rewrite that here. Let's rewrite under here. Sine of A over cosecant of A plus cosine of A over secant of A equals what? Cosecant squared A minus cotangent squared A. Verify that this is an identity. Yikes. Sine of A over cosecant of A plus cosine of A over secant of A equals cosecant squared A minus cotangent squared A. Verify it's an identity. All right. Where do we start? Well, we're supposed to start with the more complicated side. What would you say is the more complicated side? Both, kind of, right? So it's okay to work with both. If we want to break down both sides, you can do that. So let's do it. Let's break down both sides kind of at the same time. How would we do that? Really, our first option, we didn't do it back here because this one was a little simpler in the sense of what we changed this to 1 over tangent and it all canceled out. But we still best practice everything in terms of sine and cosine. Looks like that's going to be the issue here. Let's leave that. What's cosecant? 1 over sine, right? So sine of A over 1 over sine of A plus cosine of A over 1 over cosine of A. Okay, so I just simplified down those trig functions. Cosecant is 1 over sine, secant is 1 over cosine. Okay, so that's my left side of the equation. Again, we started with that side, but we're also going to do the right side. All right, so we're ready to simplify the right side. Same idea. Now I need to take the right side and break it down into simpler terms. So cosecant squared A. Again, if our formula sheet comes in handy, look on it. Where is cosecant squared of A or of theta or of X? Again, it doesn't necessarily matter. The only one I'm seeing there is 1 plus cotangent squared. So let's plug that in. 1 plus cotangent squared of A. All right, what about then cotangent squared? What can I change that to? Well, got a couple different options. I could change it to cosecant squared theta minus 1. Okay, but then I just kind of be going in circles. What if I just left it? Look at what we have here. 1 plus cotangent squared of A minus cotangent squared A. Hopefully you can still see that. Okay. Notice we could have changed cotangent squared into something else, but when I did this first one, cosecant, when I change it to cotangent squared of A, I noticed that that's a plus and that's a minus. Let's just leave it because they're going to cancel out. That's what I want to happen. I want it to get simpler. So because that right side's almost done, let's just finish it. Plus minus is 0, 1. So if we do it right, the whole left side should cancel to be 1. Let's see what happens. Okay, and then the trig identity would be verified. Sine of A over 1 over sine of A. How do you simplify a fraction over a fraction? Flip and multiply, right? Flip the bottom and multiply. So in other words, sine of A over, I flip the bottom and multiply. Sine of A over 1. Pause there. Let's do the second one. Cosine of A times cosine of A over 1. Okay, now let's just multiply across. What's sine of A times sine of A over 1? Sine squared of A, right? Sine times sine is sine squared. Cosine times cosine, cosine squared. All right, junk. Are we any closer? We're trying to get this identity to be equal to each other. But now we're stuck with sine squared, cosine squared. Can we change that to anything? Lo and behold, first option under Pythagorean identities. Sine squared theta plus cosine squared theta equals 1. I'll give you a hint. That's one that you should know. That one comes up a lot. 1 equals 1. Look at that short answer in the blank. Into blank goes 1 equals 1. This was the original problem. All that shook out to be just 1 equals 1. Those two identities are equal. We have verified it. All right, that's really the main meat of this lesson. We got just one more point. So stick with me, we're almost done. The last point for today. We verified. We couldn't get by today without doing just a little bit more. Simplify. Number 2. One more definition. Here it is. It's a short one. Read it for you. Simplifying functions. Break down an equation to involve only a single trig function. Break down an equation to involve only a single trig function. So we're going to be given a long equation. All of them will be able to be simplified and broken down to just be one function. In other words, sine. cosine, cosecant, whatever it might be. There's just going to be one trig function left. Last example. Here's the instruction. Find a numerical value of one trig function of x if, let me erase that a little more for you so the smudges aren't in the way. Okay. Find a numerical value of one trig function of x if, here's the problem, cotangent of x over cosine of x equals 2. Okay? Again, essentially what we're trying to do here is we're trying to get one trig function that equals the value. In other words, the numeric value is 2, but what is that numerical value of just one trig function? So one trig function equals that number. Again, once we have one trig function, our work's done in this case. So find a numerical value of one trig function of x if, and then they give us the problem, cotangent of x over cosine of x equals 2. All right, what should we do? Well, what can we simplify? Not cosine, we can simplify cotangent. A couple of different options. If we have cosine, we probably want to put it in terms of sine and cosine. What's cotangent of x? Cosine of x over sine of x is what cotangent equals. That's all over cosine of x equals 2. Fraction over fraction, flip and multiply. Think of this over 1, right? So I'm going to flip and multiply. Here's my first one, cosine of x over sine of x times 1 over cosine of x. When you flip and multiply, look what happens. Cosines cancel. What are you left with? This all equals 2. So what are you left with? 1 over sine of x. Are we done? Not quite. Good to put it in the best, simplest form. What is 1 over sine of x? Cosecant. Cosecant of x equals 2. Again, your work is done when one trig function equals the value. Cosecant of x equals 2. All right, so pretty straightforward. The only difference there is you'll be given a problem and you'll have to simplify it down and just be one trig function.